Hi, my name is Harshit, and the topic of my video presentation is FP growth. FP here stands for frequent pattern. Okay, so what is FP growth? It is an efficient and scalable method to complete set of frequent patterns, and it allows frequent item set discovery without candidate item set generation. So it's a two-step approach. First is build a compact data structure called the FP tree. Second is extract frequent item set directly from the FP tree. So here's an example of FP tree. Suppose we have the following database. Uh, Here's the table. So it contains transaction IDs from 1 to 8, and these are the items. Okay. So to build the FP tree, we'll first calculate the minimum support. In some cases, the minimum support is already given. So here it is given in the form of percentage. So here it is given 30%. So we'll calculate it. We'll divide 30 by 100 and then multiply by 8 because we have total 8 transaction IDs. So we'll get 2.4. So 2.4 appears but to Empire easy the collection. So we'll round it off to the ceiling value. So we'll get 3. So we'll discard all the items which will have frequency less than 3. So we'll only take items which will have frequency 3 or greater than 3. Okay, because it is our minimum support. So now we'll find the frequency of occurrence of each item. Okay, so now here we have transaction IDs, we have items. So let's start with A. So A here comes 1, 2, 3, 4, and 5. 5 times, so frequency is 5. Similarly, B here comes 1, 2, 3, 4, 5, 6. So frequency is 6. For C, we will have 1, 2, 3. We'll have frequency 3. D, we have 1, 2, 3, 4, 5, 6. So D also have frequency 6, and E has frequency 4. So we'll create a separate table for this. Okay. Now we'll prioritize the items according to their frequency. This means the item with the highest frequency will have the greatest priority. So uh, B has the highest frequency of 6, so its priority will be equal to 1. D also have frequency 6, so it will have priority 2. Now A has frequency 5, so it will get priority 3. And then we have E have frequency 4, so it will get priority 4. C has the least frequency of 3, so it will get priority 5. So we'll make a table like this. Okay. So we have seen the we have seen table 1. Okay, so we will now reorder the items according to their frequency. So previously the table consists of this only. So we will write ordered items and then reorder the items according to their priority. So here we have E, A, B, D. So the B has the most frequency. B has the most priority. So it will come. Uh, so it will come first, then D, then A, then E. Similarly, we will do this for all the items on this list. Okay, so this will be the new version of the table. So uh, now we'll start constructing the tree. Okay, so for first row we have items B, D, A, E. So uh, the FP tree will always have the root node as null. So here we can see null. First row has items B, D, A, E. So uh, we will draw a branch for the first row. So we have B, D, A, E. Okay. So we will write their occurrences in front of it. So B occurred for one time. So B, D, A, E. All of them occurred once. So we will write one in front of them as their occurrence. Okay. So this will be the FP tree for row 1. Okay. Now we have row 2. So the ordered items are as follows: B, D, A, E, C. Okay, so we can see previously the occurrence of B was one. Okay, so B occurred here. So we will write the occurrence of B as 2. Then D is also here. So okay, just a moment. D is also here, so we will change the occurrence of D from 1 to 2. Similarly, we will also change the occurrence of uh, A from 1 to 2 and E also. But we can see that C has occurred for the first time, so its occurrence will be 1. Okay. Now we have row 3. So the ordered items are B, A, E, C. So you may think you can follow the same branch again by replacing the values of B, A, E, C, but you can't do that. You have opportunity to come through B. Okay, so you can't just go from B to A like D does not exist. So that's not how you will do it. So you will change the occurrence of B from 2 to 3, but then you can't go to A. Okay, you can't go to A, so you will create a separate branch from B, you know, and then you will have items A, E, and C, and you will write their occurrences in front of them. All of them has occurred one time, so you will write one in front of them. Just a moment. Okay, so this is our row 4. Now we'll head on to row 5. So we have only D over here. So we can't go to D directly from B. So we'll create a separate node uh, that will be attached to the null node. Okay, we'll create a new branch that will be attached to the null node, and we'll mark the occurrence of D over here as 1, as D has occurred only once. Okay, now we'll move to row 6. So B and D appears in row 6. Okay, so just change the uh, B4 to B5, B4 to B5, and D3 to D4. Okay, we'll change this. Now row 7, we have A, D, A, E. Okay, so attach two new nodes, A and E, to the D node. Okay, and then mark the occurrences of D. Okay, previously D was 1, so we'll change it to 2, and A and E has occurred only once, so we'll write 1 in front of them. Now A, now 8th row, the last row, we have B and C as our ordered items. So attach new node C to B. Okay, because we can't go directly from B to C. Okay, so we'll attach a new node C, and we'll change B. Previously it was 5. Okay, B here was 5, so we'll change it to 6, and we'll write the occurrence of C in front of it, which is 1. So it's the final FP tree. So how will we validate our FP tree? So we have to count the frequency of occurrence of each item of the FP tree and compare it with table 2. If both counts equal, then it is positive point to indicate your tree is correct. Okay. So there are certain advantages and disadvantages of FP growth. So advantages are only 2 passes over data set. It compresses the data set and no candidate generation. So disadvantages of FP growth are tree may not fit in the memory, and tree is expensive to build. Okay, that's it.